There has been much hype over the past few years on the rise of quantum computers and what it has to offer to further increase humans' technological advancement. But are quantum computers really faster than classical computers? Before we find out how a quantum computer works, let's take a look at our classical computers. The most basic unit of information in a classical computer is a bit. It can exist in two different states, either 1 or 0, or pen or an apple. Classical computers are able to perform various operations with the help of logic gates. A logic gate can be thought of as a gatekeeper who allows certain people to pass through the gate if they pass a certain test. For example, an AND gate gives an output of 1 when both the inputs are 1s, and an output of 0 otherwise. An arithmetic operation can be performed by a combination of logic gates, and a series of arithmetic operations gives us programs which we can use in our daily lives, from online banking to gaming. So, what makes quantum computing so different and interesting? In the quantum world, things behave differently. Instead of existing as two different states, a quantum bit, also known as a qubit, can exist as superposition of these two states. This would mean that a qubit can exist as both states simultaneously until we observe it, which then manifests itself as either of the two states. This superposition gives rise to the intrinsic randomness of the qubits. Another interesting property of qubits is that they can be entangled. Entangled qubits have strong correlation between them, even if they are separated at great distances. When two qubits are entangled, by observing one qubit, we can immediately know the state of the other qubit. Quantum computing leverages on the strange properties of qubits to potentially operate faster than classical computers. However, to manipulate qubits, quantum gates are required. In contrast to classical logic gates, quantum gates takes in qubits and alter the probabilities associated to each state. For example, if you place a qubit through an X gate, you will swap the probabilities of the two states. A clever use of quantum gates in quantum algorithms can allow calculations to be performed much faster than any classical algorithm. Practical applications include database searching and factorization, which is widely used in security protocols. A classical computer will take many years to crack a credit card's security, when a quantum computer can possibly do it within a day. Another area where quantum computers can be utilized is in large simulations. Classical computers simply do not have the horsepower to compute such complex interactions as they grow exponentially with the size of the system, but the properties of a quantum computer can be exploited to perform such calculations efficiently. However, quantum algorithms are highly problem-specific. Only certain problems can be solved faster via quantum computers, whereas for most applications, such as gaming, it is still faster when run by a classical computer. So, is a quantum computer really faster than a classical computer? Fundamental differences in the properties of the computers are what allows a quantum computer to solve certain problems with much greater efficiency. However, the speed advantage of quantum computers over their classical counterparts are highly limited to specific problems. Whether or not quantum computers are faster than classical computers in the future depends on our ability to identify such problems where quantum algorithms or properties can be exploited.